What's up, people? Welcome to today's session. My name is Anoop and this is Vedantu. Today is going to be the day, people, where we're going to be doing some very important questions, some most important questions of physics of both electricity as well as magnetic effect of electric current. Both of these, which is going to help you to score 95 and above in your pre-boards. And I'm pretty sure that none of you guys want to score anything less than that. So this is your chance to get on board and get those practice questions done so that you can ace those exams. So I'm going to give you 10 questions back to back to back. Get your pen and paper ready and make sure that you guys do it with me, solve it with me. Before that, Merry Christmas, people. Merry Christmas and a Happy New Year in advance. I hope that you guys have a fantastic year ahead. At least 2021 should not turn out as 2020. I hope, fingers crossed, touch wood, I hope that's the case. Anyways, with that said, let's get into today's session. Let's start with electricity and then we'll move on to magnetic effect of electric current as well. So 10 questions back to back, 5 questions from electricity, 5 questions from magnetic effect of electric current. All questions very, very important, starting from 1 mark questions all the way to your 5 mark questions. So let's get started without wasting any more time. The first question, here it is. Two resistors of 10 ohms and 15 ohms are connected in series to a battery of 6 volt. How can the values of current passing through them be compared to? Is it 1:1, is it 1:2, 2:3 or 3:2? Two resistors, so if you have to draw it out, this is what the circuit would look like. So two resistors, one is 10 ohms, the other is 15 ohms, connected to a 6 volt battery. What do you think would be the ratio of current passing through them? It's actually a very simple question, guys. If you just understand the logic that in series circuit, the current passing through both the resistor is going to be the same. The same current is passing through it. So the ratio would be 1:1 because the same current. See, in parallel connection, the current is going to be different. But in series connection, it's going to be the same current, and hence the right answer is 1:1. Guys, it's a simple 1 mark question, direct explanation. There is no need for you to do the calculation. There's nothing required. If you want, you can calculate the current individually and you'll still end up getting the same answer itself. If you want, you can try it out. It's going to yield you the same results. So this is the answer for the first question. Moving on to the second one, guys. Yet another easy question as well. Again, something related to resistance this time. One of two wires X and Y shown out of the two wires X and Y is shown below, which one of them has the greater resistance? And justify your answer. It's a 2 mark question. So this is both of them have the same area, the cross-sectional area is the same, but then the length is a little different. The length of wire Y is actually twice the length of wire X. So what do you know, people? You know the answer for this question. R is equal to rho L by A. So if you remember, resistance is directly proportional to L, and because of the fact that wire Y has a longer, it's basically longer than the first one. So if this is for R1, let's say this is R1, the resistance for the first wire, resistance for the second wire would be basically twice the length. So it's going to be obviously 2 times more as well. Because why? As the length increases, the resistance also increases. Because wire Y is longer, the resistance over there is also going to be longer. So the right answer is wire Y. Again, don't worry, guys. All the notes would be in the downloadable form, so don't worry about it. You can download, just click on the link, click on the description, and then you can download all the notes as well. So that is the answer. Why Y has greater resistance as it has more length compared to X is because the resistance is directly proportional to length. That's all. So that is the answer, people. So here, this is what is going to happen. So for the second wire, it will be R is equal to rho 2L by A, because the area is the same, but the length is going to be twice of it. So yes, resistance is also going to be according to that. All right, next question. VI graph, that is voltage current graph of two wires A and B, are shown in the figure. If both the wires are of the same thickness and same length, which of the two is made up of a material of higher resistivity? Give justification for your answer. Yet another easy question for 3 marks. Such another easy question for 3 marks, people. Do not miss out on these simple questions. Even if you lose marks in the other questions due to calculation mistakes and all, these direct answers, you don't worry much about it. Anyways, the options are option A, B. Is it A, wire A? Is it wire B? Is it both A and B having the same resistivity, or can't say? It's early in the morning, people. So yeah, I'm blabbering a lot. I'm really sorry about it. So A or B, which of this has greater resistivity? And the answer to this question, guys, is actually going to be A. You know why? Because if you compare both of them, A has greater slope, right? And more is the slope of the wire, more is going to be the resistance as well, right? So resistance is going to be more if the slope is more. Simple. So here A definitely has greater slope compared to B, and hence the resistance of A is definitely great. Now remember, if you go back to the formula again, resistance is equal to rho L by A. So that means resistance is directly proportional to resistivity. Because the resistance of A is greater, the resistivity of A will also be greater. No doubt about it. It's going to be, because it's directly proportional. One is dependent on the other. So if the other one increases, this should also increase. If resistivity increases, resistance should also increase. If resistance decreases, resistivity should also decrease. So here, because R is directly proportional to rho, you can say that wire A has higher resistivity. 3-mark question, people. 3-mark question. Understand the importance of it. Such simple questions is what you can expect in your board exams as well. Another 3-mark question, which is also a very easy one. A simple circuit is given to you. Let's take this is R1. I'll take this as R2. Let's take this as R3, R4, and let's take this as R5. All right. So how you want to name it? Name it whatever way you want. So you're supposed to find out what is the current flowing through the circuit. You're supposed to find out what is this current flowing through the circuit. So first of all, find out the equivalent resistance. Find out the equivalent resistance. The options are 1 ampere, 0.5 amperes, 2 amperes, or 2.5 amperes. It's actually quite simple. So I'm going to do it over here, a little bit of over here, and then I'll do the rest in the rest of it later. So first thing first, people. Here, these two are in series. R3 and R4 are in series. So I'll just write it as RS, which is the resistance in series, is equal to R3 plus R4, which is equal to 1 plus 3, which is equal to 4 ohms. So I can simplify it. So what will happen to the circuit? This is what my circuit looks like right now after I simplify it. So I have yes, this is what my circuit would look like, right? So yeah, right, simple. Right, so again, this is going to be 3.6 ohms. This is going to be 6 ohms. This is going to be 4 ohms. And this is going to be 3 ohms, right? Now first, next thing, solve this one. They both are parallel. They both are parallel. So find the equivalent resistance over here. So 1 by Rp, which is nothing but parallel resistance, is equal to 1 by 6 plus 1 by 4, because 1 by Rp is equal to 1 by R1 plus 1 by R2. Here again, it'll be what? It'll be 1 by R2 divided plus 1 by R2 plus 1 by RS. So again, 1 by R1 plus 1 by R2. If you remember the equivalent resistance, I don't have to explain it. No. Anyways, so basically what would happen to this, simplify the equation, find out the LCM. So I'm going to cross multiply this. 4 plus 6 divided by 4 into 6. So that's 10 divided by 24. 4, 5, 20, 4, 6, 24. Yeah. So this is 1 by Rp. So 1 by Rp is 10 by 24. So what is Rp? Rp is reciprocal of that. So it'll be 24 divided by 10, which is nothing but 2.4 ohms. So what will happen to the circuit now? Now my circuit would look something like this. This is what my circuit, I'm trying to simplify the circuit as much as I possibly can. So what happens in the circuit now? It will be 3.6 plus this is 2.4 and this is 3 ohms. Simple. Now they're all in series, added up. So the equivalent resistance R equivalent is equal to 3.6 plus 2.4 plus 3. That's all, people. 3-mark question. I know that it seems a little longer, but it's actually pretty easy. It's pretty easy. It's just a little bit of calculation, that's all. So 3.6 plus 2.4 is, that's 5, that's 6. 6 plus 3 is equal to 9, right? So the equivalent resistance is going to be 9 ohms. Now, the question is not to find out the equivalent resistance, but to find out what is the current flowing through it. If you remember the formula from Ohm's law, I is equal to V by R. V is 4.5 divided by equivalent resistance is 9. So 4.5, that's 2 is 9. So it'll be 1 by 2 ampere, which is nothing but 0.5 ampere. 3-mark question, guys. 3-mark question. And the answer is going to be 0.5 amperes. I'm pretty sure that everyone will be able to do this question. It's a pretty damn easy question. Again, guys, You can download all the notes, so don't worry. Whatever I've written over here, everything can be downloaded. So don't worry about it. Chill out, relax, but do it with me. All right, do it with me. Don't just ignore it. Do it with me so that you're able to solve it before I do. All right, another 3-mark question. An electric bulb of resistance 200 ohms draws a current of 1 ampere. Calculate the power of the bulb, the potential difference at its end, and the energy in kilowatt hour consumed burning it for 5 hours. It's a very awesome question. Trust me, you would love this question. It's actually one of the most simplest questions that you have. It's the options are 1 kilowatt watt hour. Is it 4 kilowatt hour? Is it 2 kilowatt hour or 0.5 kilowatt hour? Okay, first of all, write on the given data. Resistance is given as 200 ohms. Current is given as 1 ampere. Awesome. First thing, find out the power. Power is equal to V into I, which is equal to, so I can substitute that in place of V, I can write it as I square IR. So I can write it as I square R. This is the formula to calculate power. Now, if you remember the formula directly, you can write it out because, if you don't want to remember all the individual formula, just remember the first formula and then use Ohm's law. So in place of V, I substituted it as IR because V is equal to IR. So it is I square R. Current is 1 ampere, so 1 square is equal to resistance is equal to 200 ohms. So that will be 200 watt. Power is equal to 200 watt. You're also asked to find out what is the potential difference. So how you find out the potential difference? V is equal to IR again. So what is I? I is 1. Resistance is 200. So it's going to be 200 watt. So you found the power as 200 watts, and you also found the potential difference is equal to 200 volt. So these two questions are already done. That itself will give you half the marks, no doubt about it. Now to find out what is the energy consumption if you were to turn it on for 5 hours. Again, energy consumption E is equal to P into T, power into time. Power is 200 volt and time is 5 hours. 5 twos are 10, so that's 1000 watt hour. 1000 watt hour. Now you're asked to find out the energy consumption in kilowatt hour. So what do? Very simple. Divide this by 1000. So here it is what? 1 kilowatt hour. Simple. Simple. Such easy calculation, people. Such easy bacha level calculation. And this is going to yield you another 3 marks. Simple, right? So make sure that you practice as many questions as you can, people. So that marks the end of electricity. Before I go any further ahead, guys, if you want to have more such amazing session and want to gain 100% knowledge of every single concept and have a lot of fun doing that, click on the link that is given in the description as well as on the pinned comment section below, people. You are going to be getting a whole array of, online learning where you have the opportunity to learn live unlimited sessions, how many ever sessions you want, unlimited live sessions. You have the opportunity to do that. With that, you have the highest level of quizzes in every single session. You have the option, you have the opportunity to compete with the rest of the world with these quizzes and see where you're really at. And if in case you miss out a session, don't worry, guys, because you have the option to take part in the interactive replay session. So if in case you miss out a session and you're not able to take part in the quiz, don't worry, we have got you covered. You can attend the quizzes after when you're watching the replay and still see yourself on the leaderboard as well. With all of these, you have the opportunity to download all the premium content of every single session. All the handwritten notes of every single class, of every single session can be downloaded and revised as many number of times as you want. It's totally up to your discretion. With this, with all of these, you have the best of the best class teacher and the master teacher working together to help you solve every single doubt of yours inside the session itself. So you'll not just have one teacher, you will not just have the master teacher, but together with the master teacher, you will also have the class teacher to ensure that all your doubts are answered inside the session itself. With this, you have the best of the best quality tests and assignments to help you improve yourself. You know that you only have 3 more months left. You know that you have only 3 more months left. So if you're someone who have already studied everything and you're planning to revise, or if you're someone who already revised and studied, if you're someone who has not started yet, does not matter what category you fall under. I'm pretty sure that all of you guys might fall under either of these 1, 2 or 3 categories, but don't worry, guys, we've got you covered. Even if you're going for revision, if you're going through revision, you can get it revised over here, people. If you're someone who's not started yet, don't worry, we're still going to help you out and make sure that you get at least 90-95%. Again, it's not just from our side, you should also put in your own effort. It's not like we're giving you blank promises. No, you should also put in your efforts from your side, but we will do our best. We'll make sure that you're getting every support that is needed to ace your exams. With all of these, you have 2,000 plus micro courses and crash courses all for free. Yes, you heard that right, people. All you gotta do is click on the link that is given in the description below and use the coupon code AMEPRO. And yes, guys, avail your amazing discounts until 27th of December. Because it's Christmas time, we've got a gift for you. 50% off on all the courses that you'll be using the coupon code AMEPRO on. So any course that you use the coupon code AMEPRO on, you're going to be getting a discount of 50%. The link is given in the description. All you have to do is click on the link and choose your grade and your syllabus and enter this coupon code and get avail that 50% discount. It's only going to be valid till 27th of December. After that, it's going to be gone. Again, it'll go back to the original price. So if you go for the 1 month program, people, it's going to cost you 2,699. But if you use the coupon code AMEPRO, you get a 50% discount and the price drops down to 1,349 rupees. If you go for the 3 month program, again, the cost is around 6,999, around 7,000 rupees. But if you use the coupon code AMEPRO, you get a discount on that, a 50% discount on that, and what you'll be paying is 4,999 only for the next 3 months. Now, remember this, people, in that 1 month, you would have attended roughly about 200 sessions in that 1 month, a minimum of 200 sessions. With what does that mean? Is if you calculate the total money that you're paying to the total number of sessions that you take, that's about 6 rupees, a mere 6 rupees per session. And if you go for the 3 month program, that's about 8 rupees per session. That's like, that's what Mangalyaaan's fuel price was. So yeah, that's how much, people, that's how much you'll be paying for a simple, for your own future, which is going to be less than a packet of lace as well. So yes, think about it. The link is given in the description. You don't have much time, people. The seats are very, very limited. It's filling up really, really, really fast. So if you're not one of them, it's okay. I'm sorry for you guys, but nonetheless, the link is given in the description. The coupon code is AMEPRO. Check it out. All right. Anyways, magnetic effective electrical, another very important chapter. Now this chapter mostly has a lot of theory in it, so there's no problems as much, but you have a lot of 5-mark questions from this coming from this chapter, especially the construction and the working of motor and using of Fleming's left hand rule, right hand rule, and the thumb rule. Very, very important concepts. So we're going to get into all of those right now. So get ready, freshen up your mind. Let's get into it. 5 questions back to back. Here's the first one. A positively charged particle, an alpha particle, is projected towards west, is deflected towards north by a magnetic field. Find the direction of the magnetic field. It's a 1-mark question. Your options are towards north, towards east, toward downwards, or upwards. First thing, guys, you have to use Fleming's left hand rule for this. What does Fleming's left hand rule say? If I extend my thumb, my forefinger, and my middle finger such a way that they are mutually perpendicular to each other, perpendicular, if it's mutually perpendicular to each other, if you extend your arm something like this, what it shows is that the thumb indicates the force experienced by the current carrying conductor. The forefinger indicates the direction of the magnetic field, and your index, the middle finger that is there, will show the direction of the current. So basically, force, magnetic field, which is represented by the letter, you can write it as M or you can write it as B. B also stands for magnetic field, and C is nothing but the direction of current, or it's nothing but I. Now, the easy way to remember this is father, thumb is father, the index finger is mother, and the middle finger is nothing but child. So father, index finger is mother, and this is child. F, M, C, father, mother, and child. So F is what? The force experienced by the current carrying conductor. M is the magnetic field, and C is the direction of the current. First thing, a positively charged alpha particle is projected towards east. So find out the direction first. This is north, this is south, and this is west, and this is east, right? So first of all, the what to say, the positively charged particle is projected towards east. Towards east. That means the direction of the current is towards east. Direction of current is towards east. It's a positively charged particle, so that is the direction of the current as well. So direction of current is denoted by this middle finger, which is towards east. Towards east, right? Now, the I would say the particle gets deflected towards north because of the magnetic field. So it gets deflected towards north, which the force that is, it is experiencing a force. That force is represented by the thumb. So basically, this is the thumb which is representing the force experienced by that charged particle, and this is the direction of the current. I hope you can see this is the direction of the current, and this is nothing but the what to say, it is nothing but the force experienced by that charged particle. So what would be the direction of the magnetic field? The direction of the magnetic field is shown by your index finger. So what is the direction line? It's going towards me. That means it is going upwards. Why upwards? Think about it. This is the plane. This is the plane. It's coming out of it. It's coming upwards, right? If this is the plane, it's coming upwards. And so you can say that the direction of the magnetic field is upwards. Now, this by far is an easy question. Trust me, it's an easy question. You just need to understand your Fleming's left-hand rule. So remember this, guys: father, mother, child, which is force, magnetic field, and the current. Now, in some questions, they will ask you, they'll tell you that the direction of an electron is so and so. Let's say the direction of the electron is going towards the west. Direction of electron is towards the west. Now, do not misunderstand that the direction of current also is towards the west. No, remember, if you remember the conventional current is always opposite to the flow of the charges, right? So what does that mean? The direction of current, if the electron is moving towards the west, would be towards east. Direction of current would be opposite to the direction of the flow of electrons. So here, if the electrons are moving towards the west, then the current is in the opposite direction, that is towards east. Remember that case. Now here it's a positively charged particle. Here, because it's a positively charged alpha particle, that is the direction of the current as well. But if it is electron which is negatively charged, then the direction of current would be the opposite direction. Just remember that, guys, because you can be, those kind of questions can be asked in your final exams, in your board exams, and your pre-boards. It can be a little confusing. So remember that, because I don't want you guys to lose that 1 mark. Still very, very important, right? Because if you want to score 90 and 95 and all, you have to remember these 3 things. All right. So that is the case. The right answer is going to be upwards. Why? It's going towards me. The force. This is the direction of the current, so it's going towards me, which means it's going upwards. That means it's coming out of the plane, so it's upwards, right? So that is the answer, guys. Moving on to the second question. A given magnet is divided into 3 parts, A, B, and C. Name the parts where the strength of the magnetic field is maximum and its minimum, and how will the density of the magnetic field differ at these parts. Your options are max at B, minimum at A and C, max at A and C, and minimum at B, max at C, minimum at A, max at A, and minimum at B. It's actually a very simple question, guys. So this is what is given. A simple bar magnet is divided to 3 equal halves, A, B, and C. Where is the magnetic field lines going to be maximum and minimum? First of all, draw the magnetic field lines. What will the magnetic, let's say that this is the North Pole and this is the South Pole. I'm just assuming this is the North Pole, this is the South Pole. So you see that this is how the magnetic field lines would look like. Yeah. Yes. I was trying to draw out love wala symbol because it's Christmas time. No, that's why. That was very intentional. Very, very intentional. Alright. So you get the point, people. You get the point, right? So it's going to look something like this. So it's very clear, people, that the magnetic field lines is going to be maximum at A and C, because the magnetic fields are always stronger at the poles. So A and C, it's going to be maximum. It's going to be maximum at A and C. Where is it going to be minimum? So inside over here, the magnetic field lines will be very, it'll be spaced. It'll have a lot of space in between, and so the magnetic field lines will be minimum at B. Now, how will be the density of the magnetic field lines differ at these spots? A and C, that is at the poles A and C, it's going to be really, really dense, and at B, it's going to be really, really well spaced. There'll be a lot of space in between. So it'll be spread out. In other words, it'll be all spread out over here, and at A and C, it's going to be very, very crowded, because obviously in a bar magnet, the magnetic field lines or the magnetic fields is always stronger at the poles. So A and C, you'll see that the magnetic field lines are more denser, whereas at B, which is in the middle, is going to be always spread out, right? So that is the answer, guys. A very, very simple question. Again, it's a 2 mark question, a very simple 2 mark question. Easy questions, people, but yes, do not make any sort of mistakes in this, all right? Don't lose marks on all these questions. All right, next question. Write one application of each of the following: right hand thumb rule, Fleming's left hand rule, and Fleming's right hand rule. It's quite simple, guys. Let me just state the state it first. Right hand thumb rule says that if I have a current carrying conductor, a straight current carrying conductor, and if I wrap, if this is the straight current carrying conductor, and if I take my right hand and wrap my fingers around it, my thumb will indicate the direction of the current, and the fingers that is wrapping the conductor shows the direction of the magnetic field. So if this is what it would look like, so if this is the current carrying conductor, this is the magnetic field lines would basically be concentric circles. So it's going to go, basically it's going in clockwise direction, in anti-clockwise direction. Anti-clockwise direction, this is the direction of the current. The Fleming's left hand rule, I've already stated. What is Fleming's left hand rule? That if you extend your thumb, your forefinger, or your index finger and your middle finger such a way that they're all perpendicular to each other, you see that the thumb indicates the direction of the force experienced by the current carrying conductor. The index finger indicates the direction of the magnetic field, and your middle finger shows the direction of the current passing, the current flowing through the conductor. So that is your Fleming's right hand rule. Left hand rule, that is your Fleming's left hand rule. Right hand rule is basically pretty much the same thing, but it's a little different. So Fleming's right hand rule states that if you extend your right arm such a way that your index finger and your middle finger and your thumb is all perpendicular to each other, just like this. So what happens is that this shows the direction of the force. This again, thumb shows the direction of the force of the current carrying conductor, and your middle or the index finger shows the direction of the magnetic field, and your middle finger shows the direction of the induced current, not current, but the induced current. So Fleming's left hand rule basically is something which is used to state that when a current carrying conductor is placed in a changing magnetic field, there is current induced inside the conductor. So that is why we use the Fleming's right hand rule. So again, this is the force. This is the force or the direction at which the conductor is moving, or that magnetic field is moving. This is the direction of the magnetic field. This is the direction of the force on the conductor. This is basically the direction of the magnetic field, and this shows the direction of the induced current, right? So the easy way to remember it is FBI. So FBI, like hands up, something like that. So that is force, magnetic field. Magnetic field is represented by B, and then induced current is nothing but I. So that's one way to remember, guys. So this is father, mother, and child. This is FBI. That is FBI. Federal Bureau of Investigation. Yeah. So yeah, remember it like that. That's all. So where do we use it for? If you talk about right hand thumb rule, it is used to find out the direction of the magnetic field in a straight current carrying conductor. Fleming's left hand rule is used to find out the direction of the force experienced by a current carrying conductor in placed in a magnetic field. So it is used in motors. If you remember, in motors we use that. If you remember the working of motor, we use Fleming's left hand rule over there. Fleming's right hand rule is used in the generators. In electric generators, to find out the induced current, direction of the induced current, we use Fleming's right hand rule. Again, guys, all the theory is written over here. I am not writing down the theory because everything is written over here. Don't worry, just download the notes. Go through all of these one more time, but I hope you guys are able to get the idea that I'm trying to take you through the entire thing in as simplest way as possible. But it's very important that you go through the notes and read your textbook as well. It's a very simple 3-mark question. Just remember these 3 laws. It's very, very important. Again, you'll be solving a lot of problems, not problems, especially in the sense they'll ask you to find out the direction of the current or the direction of the induced current, like what we just saw right now. So they'll ask that, and also in the working of motor, you would need this. Working of generators are not there, but working of motors definitely in the syllabus. So you have to remember that, right? Next question is again. Heroes back. Explain the construction and working of an electric motor using a well-labeled diagram. 5-mark question. For sure, if this question comes, it's going to be a 5-mark question. So it's a very, very important question. First of all, draw the diagram. All right. So I'm going to start with this one. Okay, let me just do it properly, people. Let me just do it properly. So first of all, draw the diagram. If you remember the diagram, so these are your permanent magnets. So this, let's say this is North Pole, this is South Pole. You have the armature coil that is present over here, and then you have the, yes, armature coil. Then you have the split rings, and then you have the brushes, right? The carbon brushes, which is connected to an external circuit, right? So that's how it goes. That's how it goes. And then you can see that the shaft, the axle is going to be somewhere in between. If you want, you can draw the axle to which you can connect fan or something like that. It's totally up to you, but I don't want to do it and mess my drawing up. It's already a very bad drawing. So yeah, I hope you guys got the idea. Now, the next thing is label the parts. That's very, very important. So this is providing a voltage V, current passing through it. Let's call it as I. I'm going to call this brush as X. This is Y. The commutator split ring, this is the commutator split ring. I'll call that as let's call it as P, and let's call this as Q. It's a split ring. And the armature coil, I'll call this A, B, C, and D. Simple. So that is the drawing. That's the most simplest, most dirtiest drawing in the world, but yeah, people get the idea. You can see the drawings and do it, right? So first of all, write out all the labeled parts. Write that down. So X and Y are they are your carbon brushes. They are your carbon brushes. Then P and Q are your split rings, your commutator split rings, split rings, right? Your commutator split rings. And then A, B, C, D is your armature coil. Yeah, that is your armature coil, right? And then you have the permanent magnets. That is what is it, north and south pole, right? And it's connected to an external circuit V, right? That's it. The external circuit which goes. This is the external circuit which is connected to a battery, which is nothing but V, right? Simple. Now, how does it work? Now I'm going to state it for you guys. I'm going to state it one step at a time, but please go through the notes for you to write, for the exact steps. First thing, when the current is passing through the conductor, when you turn on the switch and current starts flowing through it, so what happens? The current will flow through. So I'll just write down the direction of the current. So current will flow through X, all right, then to P, which is first of all the brushes, then the commutator split ring, then it will go through A, B, C, D. This will be the direction of the current. It will pass through this, and then it will flow out through Q, then Y, and then back to the battery again. That's how it goes. Now, what happens is this, guys. When current is flowing through this conductor, remember, when a current carrying conductor is placed in a magnetic field. So magnetic fields is this is a magnetic field. It's passing from north to south pole. So these are the magnetic field lines. I'm not going to mess it up. I'm going to erase all these things, guys, so that you can because I don't want to mess the whole diagram up. First of all, it's a messed up diagram, so I don't want to mess it even further. So you remember that the direction of the magnetic field lines are going from north to south pole. When a current carrying conductor is placed in a magnetic field, it experiences a force, right? So here also what happens? The armature coil, that is ABCD, will experience a force. Now, what I'm going to do is I'm going to use Fleming's left-hand rule to find out the direction of the force that is experienced by this armature coil. So this armature coil and the split ring is free to rotate. The armature coil and the split ring is free to rotate, all right? And it's connected to the external circuit with those brushes X and Y. That's how it goes, right? So when the current is flowing through the conductor, the direction of the current, remember Fleming's left-hand rule? This is the force, this is the magnetic field, and this is the current. So current is moving this way. The magnetic field basically, okay, the current is this way. The magnetic field lines are this way. So what would be the direction of the force? The force experienced by that conductor, or that on AB would be what? The force experienced by AB would be downwards. So what will happen? This will move downwards. AB will move downwards. Now look at B. Look at CD. CD, the direction of current is this way. The direction of current is this way. The magnetic field is exactly this way. The force experienced by the conductor is upwards. So this will experience an upward force, whereas AB on the other hand will experience a downward force. So what will happen is that this armature coil will basically it will start to rotate. It will start to rotate and it will reach halfway. When it reaches halfway, what happens is that there'll be a disconnection happening. Why there's a disconnection? Because there's a split ring and there's a gap in between. So once it reaches halfway through, the gaps in between would ensure that there's no more current flowing through it. But because it has already reached over here, because of the momentum, it will complete the rotation. So basically what I'm trying to say is, if this is the armature coil, it will rotate halfway. Why? Because of the force experienced by the conductor. Once it reaches halfway, it will not stop there because it is already having some momentum. It will complete one rotation. So it will complete one rotation. Then what will happen to the circuit? So what will happen to the armature coil is that from ABCD, now the armature coil would look like this. The armature coil would look like this. It'll look like, yeah, it'll be like, this will be D. All right, my God, all right, where did I go? All right, so this will be D now. This is going to be D. This is going to be C. This is going to be B, and this is going to be A. So it gets turned around. And if you look at the commutator rings also, the commutator split rings, this will be Q and this will be B. Again, it gets rotated. Again, what will happen? So now, what is the direction of the current now? So the direction of current, look at it carefully. It will start at X, then go to Q, then it will be DCBA, and then it will be P, and then again back to 1. So this is the direction of the current now. So again, the direction of current changes. Again, this will experience a force. Again, what will happen? Because of the direction of the current, now the current is going this way. So again, the direction of the current is this way, and then as the direction of current is this way, the magnetic field is this way. So the force experienced by the conductor is going to be, so current, magnetic field, direction of the force would be downwards. So it will again experience a force. So this will move downwards. This will again move upwards. Again, direction of current is basically this way. So what will happen again? The current is this way. The magnetic field is this way. So it's going to be like this. And the force experienced by the conductor is upwards. So it will move upwards, and this will continue to do so, and it will continue to rotate. And if you have connected an axle, this will also continue to rotate, and that will in turn rotate a fan or anything that is connected to that particular axle. Right, guys, that is it. That is basically the entire explanation. I hope you are able to understand this. Now again, don't worry, all the notes are here. This is the diagram. You can go through the diagram. So this is C1. Here they've mentioned as C1 and C2. C1 and C2 are your commutator rings, and B1 and B2 are your brushes, are the carbon brushes, and then your ABCD is your armature coil, right? So again, the currents, you have all the notes over here. So don't worry, people. I've explained it vaguely over here. I hope you are able to understand step by step. I was trying to show it to you guys, but yeah, all the written notes are here, handwritten notes. You can go through it. If you're still confused, go through all of these and understand it, because it's a 5-mark question, so you can't ignore it. So make sure that you go through this, guys. It's very easy. It's very easy to understand. All you have to do is go through the diagram and go through the solution. You'll get the answer. Alright, people, I hope you understood this. So again, the current is continuously getting reversed because of that, because of the rotation of the armature coil. And again, the force, it is experiencing a force, and it will continue to rotate as long as it's connected to the battery. As long as the switch is on, it will continue to rotate like that. Right? Next question, the last question for today, guys. That's it. With the help of a diagram, describe an activity to show that an electric current can affect a magnet. With the help of a diagram, describe an activity to show that electric current can affect a magnet. It's actually very simple, this thing. So for example, you can use right hand thumb rule for this. So imagine I have a straight current carrying conductor which is placed I have a plane. So what I'm doing is I'm placing the current carrying conductor through this plane. So this is connected to let's say it's connected to an ammeter, and then it's in turn connected to a cell, and it's in turn connected to this. Okay. So here's the thing is, when current is flowing through the conductor, all right, let's change this up a little. I'll just change the direction of current a little so that it'll be easier for us to denote. It's all right. So this is the direction of the current. So current is flowing this way now. Current is flowing through the conductor, coming out of it. Now, using the right hand thumb rule, I told you that if you place the current carrying conductor, if you hold a current carrying conductor such a way that the thumb indicates the direction of the current, and your forefinger, your middle finger, your little finger, all of that enwrapped over the conductor will show the direction of the magnetic field. So the magnetic field around this would basically be concentric circles on this plane. So how do you show? What are the experiments that shows that when current flowing through a conductor affects a magnet? Is very simple. If I bring a compass, the directional compass, if I bring it near it, the compass needle will start to deflect. Why does it deflect? Because a current carrying conductor will have its own magnetic field. So the magnetic field of the current carrying conductor and the magnetic field of the needle that is inside the compass will start to interact, and it will always, the compass will always, if you keep changing the position, it will always point, it will actually make a concentric circle. Even the needle will actually show a concentric circle itself. If you try to plot all the points, that will also be in concentric circles itself. Will show the concentric circle itself. This is one experiment. Another experiment is basically you can use the same exact thing. So instead of using a compass, you can use iron filings and do the exact same thing. If you take iron filings and place it on the sheet, you see that, on the cardboard, you see that, and just shake it a little, the iron filings will again take concentric circles. Why does it take concentric circles? Because the magnetic field lines are around the current carrying conductor is concentric circle. So those iron filings will also take those concentric circles itself. Yes. That is it, guys. That is it. So these are the iron filings which will go round and round and round concentric circles, because again, those are the magnetic field lines around a current carrying conductor. Here they've connected a rheostat, they've connected a key, ammeter. If you want, you can connect a rheostat. That's totally up to you guys. It does not really matter much. Over here, this is the compass. So you see the direction of the compass. The direction of the compass, again, this is the direction of the magnetic field. So the direction of the magnetic field is going to be something like this. So the compass will also point towards that particular direction. It will also, if you keep it in, see, this is the direction of the compass. You see, this is the needle over here, the needle over here. It is also showing concentric circles itself. Right, guys? So these are the experiments to show that the electric current, current carrying conductor is affected, or basically a current carrying conductor has a magnetic field around it, or a current carrying conductor can affect a magnet as well. That's it, guys. That is all. Those are the questions. Again, you can find out all the notes over here. It'll be given in the description. Once again, the link for your the pro subscription course is given in the description. Click on the link and enter the coupon code AMEPRO to avail you 50% discount. It's only till 27th of December, so don't miss out on the opportunity, because yes, there are a lot of enrollments happening. And once again, guys, thanks a lot for all the wishes. I got so many mails in the past 2 days wishing me a Merry Christmas. I'm sorry that I could not reply to all of you guys, but I wish you guys a very Merry Christmas from the bottom of my heart. Thanks a lot, people. Thanks a lot for all the support and love. Keep loving us, keep supporting us. I'll see you guys soon. Take care of yourself. This is Anoop signing off for the day. Do not forget to subscribe to the channel, hit that like button and also bell icon as well to get yourself notified. I'll see you guys soon. Once again, guys, practice every single question. And practice the same type of questions again and again and again. Make sure that you go through the notes as well that is given in the description for all the theory part, and score 95% and above. Right? I'll see you guys soon. Take care of yourself. Stay safe and bye bye. See you all guys.